Welcome back. Today I'll be modifying the code to my DIY Smart Security Camera Python project, and we'll be adding support for the GPIO pins on a Raspberry Pi, which will allow us to control external circuits and devices such as a nightlight. If you're a first-time viewer and want to follow along, then be sure to watch the playlist for this project. The link is in the video description. Now you might be wondering, why don't I simply just purchase a motion-activated nightlight? Well, the reason is because I want the light to be located inside the house like you see here, not outside where someone could damage it if they really wanted to. These motion-activated lights use a PIR sensor to detect motion, but these sensors don't work through glass since the frequencies are reflected off the glass. So instead, I'll be relying on the camera and an image processing algorithm that's already in the program to detect motion, and we'll use the Raspberry Pi's GPIO pins to activate a little transistor circuit that I built to control the LED. If you're interested in learning the basics of electrical engineering so that you can build your own circuits for this project, then you should check out my playlist titled Practical Electronics and Circuits 101. The most recent video in that series covers transistors and goes over everything you need to know to design your own transistor circuits on a breadboard, which is useful for controlling DC-powered devices. And then you can transfer that breadboard design to a strip board like I did here. But something I forgot to mention in that video is that you can also purchase pre-built transistor modules, which will save time if you don't want to build your own. I also wanted to mention that I'm planning to do another video in the Practical Electronics 101 series that will cover relays, which will allow you to use AC voltage devices in your projects. For example, if you wanted to use a traditional light that's directly powered by the AC mains in your house, then you can do that with a relay circuit connected to the Pi. So if you're interested in learning how to use relays, then be sure to subscribe and stay tuned for that video. Now, I should also point out that my particular use case with the nightlight might not be useful for everyone. Since the program uses the camera for motion detection instead of a sensor, this means that it won't work in a pitch black environment. The only reason it works for me is because I already have a patio light which provides enough illumination so that if someone were to come up to the door, then the camera will see a shadowy figure approaching, which is enough to trigger the motion detection. But in other situations where there's no patio light and everything is pitch dark, then this approach would be pretty useless, in which case you'd likely want to use a PIR sensor instead, which can be purchased for only a few dollars if you wanted to integrate that with the Pi. But like I said earlier, these don't work through glass, and in my particular case, I want everything to be inside the house, so a PIR sensor wouldn't work for me here. But I might cover these in a future video that focuses on how to use the Raspberry Pi's input pins in Python. Now, since my nightlight example might not be useful for everyone, I also came up with a slightly different example. A small warning light that will blink whenever the camera is recording something. Let's say you set up a camera outside your house and you want to be alerted whenever it's recording something. Well, you could set up a Raspberry Pi with a small red LED in your room, kitchen, or anywhere else in your house that will blink whenever the camera is recording. So that's what I'll be doing first. I'll be modifying the code to have this functionality, and I'll be doing the whole thing step by step so I can explain my thought process along the way. Then afterwards, I'll compare that code to the other code that I made to control the nightlight and show the differences in case you wanted to do that instead. And in case you're curious about the LED I'm using for the nightlight, I'm using two of these basic 12-volt LED rings I got from AliExpress for only a few dollars each. One of them is a smaller diameter than the other one, and I fit both of them into a 3D printed circular enclosure like you see here. Connecting these to a transistor circuit is even more simple than the example I gave in my transistor video, since these don't require a current limiting resistor. Simply connect the positive side of the LED to the positive power rail, and connect the negative side to the transistor. But the exact light you choose doesn't matter from a coding perspective. So the first thing you'll need to do is install the appropriate GPIO library on the Raspberry Pi, which I already went over in a previous video. So if you want to follow along with this today, then you should definitely watch that video first. The link is in the video description. In that video, I showed how to install two libraries for the GPIO pins. The first one is called Python rpi.gpio, and this is for running Python programs directly on the Pi. The second library is just called PyGPIO, and this allows you to control the GPIO pins from a separate computer over your local network. This is the library I'll be using since this program is meant to run on a desktop or laptop with a dedicated GPU. The Raspberry Pi will simply listen for commands from the computer. But something else I need to point out is that since this library communicates over your home network, that means it requires a specific network port. In this case, it uses port 8888. Now, if you followed my guide showing how to set up an RTSP camera stream on the Raspberry Pi using MediaMTX, then you'll likely run into problems if you try to run both MediaMTX and the network GPIO library on the same Raspberry Pi. This is because MediaMTX uses several different ports, and one of them happens to be port 8888. So this will conflict with the GPIO library. Fortunately, MediaMTX only requires this port for HLS streams, not RTSP streams. So we can safely disable HLS support, which will free up port 8888. To do this, simply go to the directory where you downloaded MediaMTX and edit the file named MediaMTX.yml. Scroll down to the HLS section and disable it. On newer versions of MediaMTX, you'll notice the comment says, "Enable reading streams with the HLS protocol." In this case, you'll change the following line to "No" to disable it. But for some reason, on older versions of MediaMTX, it will have the opposite configuration, where the comment says, "Disable support for the HLS protocol." So in this case, you'll change it from "No" to "Yes" to disable it. It's a little confusing why they would reverse these settings in the newer version, but either way, just make sure HLS is disabled. Again, you only need to worry about this if you're using a single Raspberry Pi for both the camera stream and the GPIO pins. If you're using a separate camera, then you won't need to worry about this. Alright, so we're finally ready to start coding. So let's start with the first example where we'll be making a red LED blink whenever the application is recording something. Here I have the project file opened, and again, I'll leave a link in the video description for the project on GitHub. And this is what the main Python file looks like. So this is actually going to be pretty simple. If you recall from my previous video where we set up the GPIO library, this is one of the examples I showed. This simply connects to the Pi. You specify the IP address of the Pi here. You can specify the pin that you want to control. And then this is a while loop that just blinks the LED. So this is more or less the functionality we want. It's just a matter of calling this code at the appropriate place. So we'll first copy and paste these two lines to import the library. We already have the time library imported in the project, so that's why I'm just copying these first two lines. And yeah, so let's go ahead and paste those here. And the next thing we'll need to do is here, these two lines, like I just said, these set up the Pi's address and the pin we want to control. So we also want to copy and paste this. And we can put this pretty much anywhere before the main loop, but I'm going to place it right here before the functions. Yeah. And the other thing I'll need to do is change the IP address to that of my Pi. So my Pi's IP is at this address. And of course, yours will most likely be different. And I want to control pin 14. And again, I explained all of this in detail, like how to determine which pin is which. In that previous video, I went over all of this. So yeah, that looks good. And next we'll be implementing this code in a function. So let's go ahead and create the function right here. So when creating a function, of course, start with def, then we can name the function. I'm just going to name it GPIO underscore LED. Now let's think about the functionality for a second. So we basically want the LED to turn on and off every second like we see here. LED on, sleep for 1 second, LED off, and then sleep for a second. But we only want this when it's recording something. So if we scroll down to the main loop, you'll notice that I have a variable here called recording. So whenever the program goes through the main loop, it's going to check, am I recording? If not, run this part of the code. Or else, if we are recording, run this part of the code. So we're going to be using that variable. So you can see here, the recording variable is set to true whenever the recording starts. So we're going to be using this variable to control the LED. So let's go back up to our function that we're making for it. And I'm going to do while recording. And now we can do our loop. So again, so LED is what I named that pin. So we just will be using that variable. So LED on, then time.sleep for 1 second, and then LED off, and then time.sleep for 1 second. Okay, so our function looks good. Now all we need to do is call this function in the appropriate place. So let's scroll back down to the main loop. So this is where the recording will actually start, is when it calls this ffmpeg function. So we can start the LED blinking right after this section here. So actually, right after we change the variable to true, then we can start the LED function. This would be the best place. All right, so normally when calling a function, you can just, call the function. So a lot of times, if you want to run a function, you can just simply call the function like this. But the problem with that is, so let's go back to the function, is, once it starts this loop, it's going to stay here, which we don't want to just stay stuck in this code. We want the main loop to continue running. So that's why instead of simply calling the function like this, we want to start it in a thread. Because if we start it in a thread, then we can have that running in parallel along with the main loop. So the program can continue running normally through this code. And then our LED function will also be running in parallel to that. So that's why we need to use threads. And you can see here, here's 3 different functions that are also running in their own thread in parallel with the main loop. So we can just copy and paste this format here. So I'm going to copy and paste these 2 lines, put them right here, and get rid of the, so we're not going to be calling, like I just said, we're not going to be calling it like normal. We're going to be calling it inside a thread. So we'll just enter that function here, GPIO LED, and we'll name this LED thread. Okay, I think that should be it. So let's go ahead and test it out. Okay, so we're ready to start the stream. So I'm going to go ahead and copy and paste this code here. And yeah, everything looks good. This is the IP address of my camera. And we're setting YOLO to only look out for a person. So it shouldn't record unless it sees a person. And I'm going to step away from the frame so the camera can't see me. So the LED shouldn't start blinking until I get into the frame. So it's going to take a second. All right, let's make this bigger. So you can see here in the bottom right, I have the Raspberry Pi set up. And yeah, and it's not blinking yet, which is good. So I'm going to now get into the frame, and it should start blinking once it starts recording. And see, there we go. It's blinking. Looks like it's working as intended. So now I'm going to step away from the camera, and the tail length is about 8 seconds, so we should see it continue to record for a few more seconds. And right about now, it should stop soon. Okay. Yeah. So you see in the terminal recording stopped, and shortly after that, the red LED stopped blinking. So now I'm going to get back into the frame, and we should see the same. Yeah. So it looks like it's working as it should. And again, I'll step out of the frame, and in about 8 seconds, it should stop again. Any second now. And there we have it. It's working as it should. So yeah, that was pretty easy. I'll go ahead and exit the program. And now let's compare it to the program I wrote for my front door with the night light. All right, so here we have the other modified program for the night light. And it's very similar to the previous example, but there's a few changes. So let's go through them. So here we have the main loop. So let's scroll down, and you'll notice that I'm not calling the LED function in the same place that we called it in the last example. Instead, I'm calling it right here. And that's because the functionality is slightly different. So in the previous example, we wanted to turn on the blinking LEDs whenever there was a recording. But in this case with the night light, we want to turn on the light if the camera detects motion. But that may or may not mean that it'll start recording, because the YOLO object detection activates after the camera detects motion. And then if the YOLO object detection detects something that you have specified, then it'll start recording. So the purpose of the night light is so that the YOLO object detection has enough light to be able to recognize an object or not. So that's why we are calling the LED thread here, right before the YOLO object detection is called. Okay? And now you might have noticed that we have conditions here. So the LED only turns on if it's nighttime and not LED on. So let's first go over the nighttime. So this program has an additional function called darkness meter. And the purpose of this function is to get a reading of whether it's nighttime or not. So the overall functionality is it takes a running average of the last 10 minutes. So every minute it'll take a reading and then add that to a ring buffer, or in other words, a circular buffer that has a capacity of 10. And then from there, we can take an average of the last 10 values. So let's go through this line by line. So first I declared a global nighttime variable. So you might already be familiar with this, but variables that are declared inside a function are separate from the global variables outside the function. But and variables declared outside the function are considered global variables. Now in Python, you can read global variables inside a function without declaring anything. But if you want to modify a global variable inside a function, then you need to declare it inside the function as a global variable. So that's what this line is for, because we're going to be modifying this variable. And next, we have the ring buffer. So this function comes from a package called numpy ring buffer. So you can see I imported that library here. So let's go ahead and take a quick look at that. So numpy ring buffer Python. So if you wanted to install this, you can install it with pip using this command here. And these are the various functions that you can use with the ring buffer. So like I said, a ring buffer is, another word for it is a circular buffer. And what it is it's used to, it's basically a list that contains the most recent values. So we can create a ring buffer of a set length. And in this case, so let's go back to my function here. So in this case, I created a ring buffer of size 10. Now, whenever we add a new value to this list, it'll automatically remove the oldest value. So in other words, it only contains the 10 most recent values. And this is how I'm keeping track of the average, or more specifically, it's called a running average. So we're taking an average of the most recent 10 values. Okay, so now this program is run in a thread in the background. So that's why we have while loop. So this will continuously run in the background as long as the program is running. And like I said, it'll run through this loop once every minute. And I did it slightly different here. So instead of simply calling time.sleep60, which would have worked also, but the reason why I didn't do that is because if we were to quit the program, it would need to wait for this loop to finish. So that means that you might have to wait up to 60 seconds every time you quit the program. So instead of doing time.sleep60, I did time.sleep2, and then this loops over 30 times. So in effect, it has the same results as time.sleep60. Okay, hopefully that made sense. All right, so then after it sleeps for 60 seconds, then it's going to check if it's recording or not. And the reason for this is because if it's currently recording, then that means the LED is on. And we don't want to take a reading while the LED is on, right? Because if it's nighttime, then we only want to take a reading if the light is off. So this is just to ensure that it doesn't take readings while the light is on. Now, the final frame you see here is what is processed here in the main loop. So, every time the main loop runs, it's processing the latest frame. It resizes it, turns it to grayscale. And then that's what we have here, the final frame. So it'll take in the latest frame that was processed, and then we compare that frame to a blank frame. And then that's how we get this brightness SSIM value is a statistical representation of how bright the scene is. Okay? And then we'll take that value and append it to our ring buffer. And then this is where I take the average. So for every value in the ring buffer, we add it to a total value, and then we divide that total value by the number of items in the ring buffer, right? That's how we take an average of something, is add all of them together and then divide by the number that we're taking. So, and the reason why this isn't hard-coded as 10, because you would assume if we're taking an average of 10 values, then we can just divide by 10. But consider the very first time this loop runs, the ring buffer is empty, and then we would add one value. So then if the ring buffer only has one value, we need to divide by 1, not 10. And then the second time it runs the loop, we would need to divide by 2 because the ring buffer only has 2 values in it. So that's what this is doing here. At the very end, it checks if the total count is less than 10, then we add 1. But if the total count is 10, then we're not going to be modifying it anymore. So then from there on out, the total count will remain as 10. Okay, so then the last part here, we take the average and we check if it's less than 30,000. If so, then nighttime is set to true. If not, then nighttime is set to false. And this 30,000 value I got from just experimentation. So I ran the program before sunset and I printed out the values that it was getting. And then after the sun set, I looked at the values and noticed that they were right around 30,000. So that level of brightness right around sunset is what I determined to be a good value for the functionality of a nightlight. But of course, in your particular scene, you might want a different brightness value to of what you consider to be, nighttime. So that's where this 30,000 came from. It was just from trial and error and what worked for my case. Okay, so that pretty much sums up the darkness meter function. So now let's scroll back down. So if it determined it's nighttime and the LED is not currently on, so this LED on comes from the GPIO LED function. So you'll notice that this is slightly different than the previous example. And the difference is because, so what it does is it turns on the LED, then it waits 10 seconds. And the reason why it's waiting 10 seconds is to give it time to start recording or not. Because just because the LED turns on doesn't mean that there's going to be a recording, because that will depend on the YOLO object detection. So this turns on the LED for 10 seconds and waits to give it time for YOLO to determine whether it's going to record or not. And then if it does start recording, then that's what this line here is for. As long as the recording is going, it'll sleep. And then when the recording is done, it'll break out of this loop and turn off. Now, the reason why I'm keeping track of this LED on variable here is because there can be instances where the LED turns on and then it doesn't see anything. So then the main loop keeps going again and again. And then there could be an instance where it detects motion again, but the light is still on. Because remember, we're keeping the light on for 10 seconds. So there could be instances where it detects motion, turns on the light, then a second later, the YOLO object detection doesn't detect anything, so then it assumes nothing is there. And then a second later, it sees more motion. Well, the light's already on, so we don't want to run the function again if the light's already on. So that's what this LED on variable is for, just to keep track of whether the LED is on or not. So if it's not on and it's nighttime, then we call the LED function. So yeah, hopefully now you have a better idea of how you can incorporate the Raspberry Pi's GPIO pins within your Python projects. And like I briefly mentioned earlier with the PIR sensor, I'll be coming back to the Raspberry Pi's GPIO pins to talk about input pins. Because so far I've only gone over output pins, but with input pins you can control the program with physical devices such as, a physical switch that you push to activate something, or there's a wide range of sensors that can be connected as an input to the Raspberry Pi. So yeah, I've barely scratched the surface of what's possible with the Raspberry Pi's GPIO pins and Python programs. So if you have any ideas of what you'd like to see added to this smart security camera project, then feel free to drop a comment and let me know your ideas. Or if you have any questions about how the code works and any questions about what I talked about today, then feel free to leave a comment as well. And if you enjoyed this video, be sure to give it a like, and if you haven't subscribed yet, then be sure to do that as well. But anyway, that wraps up today's video. Thanks for watching, and I'll see you guys in the next one.